My name is Wim Korver. I'm director of the Goudappel Groep and one of the sponsors of the study project STAD. And I have the honor to chair this session this afternoon. The webinar is the start of the automated driving online college tour, Spatial and transport impacts and meaningful human control. In total, 5 webinars will be organized, and I think all of you understand that in normal situations we would meet physically, but now things are a little bit different and we are doing it this way. Automated driving is forming already for many decades a scientific topic. Also in my own career, already a long time ago, as a young researcher at TNO, I studied the promising future of automated driving. But the last years, automated driving moved from a research topic to actual application in the real world. Consumers can buy and use, to some extent, automated vehicles. This means that the need for knowledge suddenly increased, which we as a mobility consultant firm experience in our day-to-day work, and which we experience in our day-to-day work every day. The college tour tries to give information on automated driving in all kinds of aspects, from more general questions on the possible implications of automated driving, which will be the topic today, to more technical aspects like what kind of infrastructure is needed or what could be or will be the behavioral impacts. The college tour is organized at the occasion of the completion of 2 major research programs, co-funded Dutch Research Council, NWO. The first is the STAD project, Spatial and Transport Impacts of Automated Driving, as part of the program Sustainable Urban Agent of the Future. And the second is Meaningful Human Control over Automated Driving Systems, as part of the Responsible Innovation Program. Some practical things for today. You can see over here that we think the total session will take about 1.5 hours. If you have questions, please state them by the chat. You can use this chat and we will, or I will gather these questions. I think after every presentation, there is a small moment for urgent informative questions. More general discussions points can be raised at the panel discussion. Of course, your microphone and video is turned off. The presentations will be published later on, and which you already know that this whole session is and will be recorded. The agenda for today. Now, I already said I will give a short introduction. My name is Wim Korver, working for Goudappel. You see me at the left-hand side. Bart van Arem will tell something about the STAD program. Here you see him on the right-hand side. Then the meaningful human control. Filippo Santoni, the CEO, will tell us what that exactly means and what the results are of the research project. And our keynote speaker from the US, Jane Lappin, will tell us about assessing the tipping point for automated vehicle herd immunity. Now, a very actual term title, I would say. And we will end with a panel discussion, and the end time is around 4:30. Now, why is it so important to study possible societal impacts of automated driving? Now, first of all, there's a lot of money going into R&D on this topic. And of course, you need a certain argumentation for stimulating this technology development. Another one is that in mobility, we really do long-term investments in infrastructure and all kinds of aspects, and that's something we experience as mobility consultant in all kinds of studies. And questions, for instance, on infrastructure. Infrastructure is for a very long time. It has at least a lifetime of 50 years. So we more or less need to know now what the future will be in 30, 40, 50 years. Also for other investments like parking garages or on-street parking, this can play a role. What kind of vehicles will be on the street and how many? Public transport, and also new developments like mobility as a service has also a link with automated driving. More practical at the moment, if we invest in infrastructure, physical, digital infrastructure, it's also important to anticipate on the coming on the automated cars. And secondly, what kind of knowledge of the future do we need now, here in the year 2020? First of all, we always have to start with what kind of future do we want? So do we need less cars, more cars? Do you want a safer society, less environmental impacts? All kinds of things are more normative. So every long-term study always starts what you really want. More practical in these long-term studies is what will be the impact of automated driving on traffic safety, environment, traffic jams, and so on. And what kind of infrastructure is needed? Can, and if so, how should we prepare for this infrastructure? And the other side can be, how can we prevent undesirable results? For instance, new accidents or new social exclusion. And more practical, how will these self-driving cars be used? These are all kinds of questions I already like to know the answer on now. For some interaction, I will try, this is a new program for me, but I will try to ask you 2 questions. I can pop up here a polling. As it is, there's a question here, and there are 5 answer options. I will click it here. And now the question for all users, already I can see that people starting there, but there are 5 options. And the question is, self-driving vehicles will come into the market the coming decades. What do you think is for our society the most important benefit? A is traffic safety. B is accessibility, less traffic jams, for instance. User needs, it's much easier to drive, and so on. Stability, less CO2, or more livability, nicer cities, nicer areas. If you have other opinions, you can give your opinion in the chat. Now I have to wait for a moment. We have, I think, around 80 users, so I will wait till we are about, say, 70 or something like that. Which I already can see that traffic safety is ahead, and now. So I will now publish it. And now you can see here on your right hand side what the final results are. And I have another question. Start a polling. And here the question is, from a technology perspective, fully automated vehicles are possible. But what kind of control and trust will consumers have about their or their automated vehicle? And in 20 years' time, kids can go to school in their personal automated vehicle. It's more limited. In selected areas or all dedicated infrastructure, fully automated driving is possible. But in others, humans are in control. Or automated vehicles will in all cases be supervised by a human operator. And I think we are now, 71. I think we stop here. So now I think there's a winner in B, that in selected areas we think that it will be completely automated, but in others not. I think this was my introduction. Bart, I think I will give you the floor. First, I have a small introduction of Bart himself. Sorry. Bart is a full professor in transport modeling and director of the Transport Institute at TU Delft. His multidisciplinary research interests evolve around modeling of the individual and collective impacts of intelligent transportation systems. He's the principal investigator of both spatial and transport impacts of automated driving, STAD. He will tell, you can already see that here in the presentation, and meaningful human control over automated driving systems. Bart, the floor is yours.
Thank you, Wim. Thank you for this this introduction. And the magical question that I always ask to my students in that case is, can everybody hear me? And then I have a look at the chat. Can everybody hear me? Yes, yes, that's good. Okay, so we're having quite a number of users in this group. I'd be also interested to see which city you're currently at. So I've seen quite some different names. I think we're across the globe. Utrecht, The Hague. I think. Wow, that, that is really quick. Frankfurt, I see. Haifa, Vienna, Toronto. That's a lot. So this is really a diverse group. Rotterdam, Jan Kees, you're in Rotterdam. That's interesting. Okay. So what I'm going to do is I'm going to squeeze 4 years of the STAD project in 5 lessons. And actually, what you see in this picture here is not the where Julio parked his car. It's a Mercedes future car on automated driving, which is in Amsterdam, and someone looking at this car and say, "Hey, what actually is this car?" And there's a lot of questions that are arising because of this. So many questions that are particularly into public stakeholders, but also private industry that want to anticipate what automated vehicles are going to mean to them. So will it be safer? So one of the options for the first poll that we did, are we going to share our cars? What's going to happen with parking? Do we still need to plan for this parking garage? How will cities evolve? So quite a lot of questions, and certainly way too many questions to answer in a single project. This is why we started the STAD project. And this is a figure from a literature study that we did with Dimitris Milakis and Bert van Wee, which kind of was the introduction also to STAD. So it's called the Ripple model, and we did survey on the literature that was available, and like 95% of the literature is mostly on technology, and there's quite some literature also on human factors and traffic flow implications. But if you look at the wider spatial implication, the implication on travel, the way we live, there's hardly any literature, and it was high time to start research in that area. And that was actually what STAD was about. And you see here the research challenges that we have been addressing in STAD. You see here we started in 2016, and we're wrapping up this year. Some of the research will still go into the next year. The overall budget was kind of 2.5 million euros. Which is a sizable budget for doing this research. We'll go through these different research challenges later on very briefly. Much more will be also discussed in the upcoming webinar. So I'm going to give you a high-level perspective on what's happening, but it's from travel and location choice behavior, freight and logistics, but also how do you prepare our infrastructure networks? What's the implications on urban design and traffic safety, and the spatial structure and economy? And there was a emphasis on economy. So we started with assumptions on what the world would look like automated driving, and then trying to understand the implications, and in the end, in terms of accessibility, traffic safety in particular, but also economy and urban quality. And as a good university, of course, projects like this, they evolve around the research done by PhD researchers and postdocs. And here you see them all, 7 of them, and I will briefly review their results and their work. And after that, I will come to the 5 lessons of STAD that I would like to share with you. So first, Baiba Pudane and I called her contribution A Day in the Life with an Automated Vehicle. And if you want to learn more, on 25th of June, she will tell more extensively about this research. But it's actually around the question, will we travel differently if we have an automated vehicle? The main argument there is that you can use your time differently in the first stages because it is convenient to drive an automated vehicle, but later on also because your travel time allows you to do onboard activities in certain conditions. And this may not only impact on if we travel more and further, but it even could change the way we schedule activities over the day. So we could buy time during the day and spend that time to other activities that can be leisure activities, that can be shopping, that can be anything that you like. So her questions are, which specifically daily changes do travelers expect with AVs? And for instance, if you would change, reason that into changes on travel behavior, would that lead to different patterns of congestion? So clearly, that's a higher level than seeing at which headways vehicles can drive. So more on that on the 25th of June. Similarly, you could also look at freight transport. And this is where Anirudh has been studying, and Anirudh's still doing this work. And on the 27th of August, he will be telling more about this. And already very early in his research, he did a literature review that was published in Transportation Research B. And researchers, they know that this is a very esteemed journal. And it actually showed that there are many different types of platooning, varying from whether you do active platooning, whether you share routes. So the level of involvement of a human operator is still important, and also a distinguishing criterion here. He also did research on the routing of platoons. So if platooning takes place spontaneously and you can contact another driver, whether you would form a platoon or not, so how do you do that? So how do you quickly find those routes? He did optimization in that and found that adjustments in time are more advantageous here than adjustments in route to form a platoon. He will tell more about that. Interestingly, he also talked to drivers, to truck drivers, so the extent to which they accept this technology, and there exist concerns about their jobs, so being less meaningful. But they also do see some benefits of platooning, but have some doubts in the capability of the system. And clearly, this is also something that probably is going to change as people do collect experience with this system. The third is Pablo, and as a psychologist, Pablo was interested in the interaction of a automated vehicle with vulnerable road users. And here you see a zebra crossing, you see a pedestrian and a cyclist, and the central question that was there: should I stop or should I cross? And how does that depend on the distance of the vehicle, the appearance of the vehicle, the speed of the vehicle, and also personal characteristics, and in particular also whether that vehicle is automated or not. So do people respond to that differently if this vehicle is automated? He will tell all about it on the 10th of September, and I can promise you that his results were, on the one hand, remarkable, but if you look at it, think about it well, maybe we could have expected this. If you want to learn more, some of his papers have already been published. The fourth researcher is Baman Madadi, and he took the viewpoint of a road operator that is confronted with the question: that roads need adaptations to be ready for automated vehicles. So for instance, to have proper lining, proper markings, but maybe also to have the digital equipment to allow for automated driving. So the question is, where do you start? So on the one hand, there are performance benefits once you start investing it. People will also start to drive differently, to travel differently. Remember the work of Baiba, that people may change their behavior. So where do you start? And this actually is a bi-level optimization problem where Baman worked on. So starting with mixed traffic on enhanced infrastructure where still the road is being shared, you could also consider gradually adding dedicated lanes. The results are interesting. You see that he's been applying that to the network of Delft. You see different parts, but also to the networks of Amsterdam, where you see sub-networks appearing that are suitable for automated driving. The fifth one is Francis Ostermeyer from the Free University of Amsterdam, specialized in regional economics. And the key question that he is looking at is, suppose that automated vehicles, they just come on demand. You don't have to park them on the streets. You can redesign your streets and find other purposes for the parking places. This has considerable welfare impact. So if you remove residential parking, then the space becomes available for other purposes like greenery, and this can improve the value of the houses. You can have commercial activities. He also looked at welfare aspects on people that do not own a car, but now that they can use a shared automated vehicle, suddenly they are in a different situation. Similarly, he has been interested in company location decisions if parking allocations change due to the availability of automated vehicles. Francis is going to present in the 25th of June. Jeroen van der Groen started later on in the project. He first did a PhD on another topic, and then as a postdoctoral researcher, he has been looking at traffic models to evaluate the automated driving scenarios, and in particular looking also at urban traffic. So how does road capacity and traffic composition change if you have autonomous and connected cars, and how can you correctly model the traffic flows at traffic lights and intersections and unsignalized intersections. This work is still ongoing, and he will tell more about this on the webinar of the 18th of June. And finally, the seventh researcher is Rianne Boersma, and she has been working together with Rotterdam University of Applied Science, and she focused especially on pilots and automated vehicles getting real. So not behind the computer or in the lab, but let's see how they work in practice. And here is a collection of the cases that she analyzed. So there was an early application in the Dutch city of Appelscha where the shuttle was used on a bicycle lane. There is a study on the park shuttle in Rivium, which actually has been running for around 20 years. I saw Dennis Mika to get there also amongst the users. Dennis, I will get to the new park shuttle as well later on. This has been operating without a steward inside the vehicle, so it's actually in our backyard. She also looked at automated vehicles in Japan, where automated vehicles were tested in a location with particularly mountains, and see how in particular the GPS signal would function, and how that was compensated also with magnetic markers in the road. So that was a short pilot that she looked at. Currently, she's shifting attention towards freight transport and looking at the container exchange route on the Maasvlakte in the Port of Rotterdam. She will tell more about it in the webinar on the 10th of September. So that gives an overall overview of the 7 researchers that have been doing work in the STAD project, and they're almost all of them are wrapping up at the moment. Next, I want to tell you a bit more about the consortium. So overall, the consortium comprises 30 academic, private, and public partners. And if they all bring 2 or 3 people, this is what a meeting, the break in a meeting looks like. So this was at Rotterdam. And the way it works in a project like STAD is all those partners provided public and private contribution to the project. So you could think of formulating case studies, and also in addition to the PhD researchers, a lot of master students also did their final thesis in the STAD project, looking also at a connection to urban design, looking at business cases, and for instance, also some of the consultancy firms looked at modeling tools, impacts, risks, and benefits. I will share some of those, some results of these contributions. By the way, you see here the list of partners in STAD. One of the topics that were taken up by several of our partners was what are smart cars and future-proof provincial roads. So we have several provinces that are a partner in STAD, and they joined forces with also the road operator, and developed a report on what the implications are on the core task and the perspective of actions of provincial road operators. So what are the design and the level of equipment that we need to maintain, and what are the actions on the short term and the long term. Surely it's clear that collaborations are needed here, but amongst the road operators, but also to work towards common design standards. And when you go to design standards and also digital infrastructure, it's clear that you need to do that also on a European level. Another example of a program that was developed in close parallel with STAD, I think actually they came about at the same moment, is the Innovation Network for Automated Transport. And the metropolitan region Rotterdam-The Hague has been starting this program in which different locations in this area were working together on experimenting with automated shuttles. And here you see on the top one, that's at the research lab, automated driving in Delft, where we had a special place where we could do experimentation with automated vehicles. The Haga Hospital, also with an automated shuttle to the public transport stop. And here you see the new To Get There vehicle, which is being implemented now as the next generation at the park shuttle. The idea is to learn together, and also as a STAD researcher, be involved in the development of these pilots and to use it as our experimental backyard. A third example is a study that was done in the province of Noord-Holland, together with some of the other partners in that region. You can see them here, where scenarios were developed on what the area could look like based on automated vehicles that could be shared also in 2014. And they used KIM scenarios. I saw Tedde Tillema as one of the users. So Tedde, we were happy to use this work. They split the area into different types. So you can have very urbanized regions, but also very rural regions, and they have different application context of these automated and shared vehicles. So they combined regular modes with different types of automated modes. They took it to the extreme, and they developed a quick scan modeling tool. And some of the highlights of this result is that yes, you do see that automated vehicles are attractive, but then it goes at the expense of other modes. And in addition, if automated vehicles would not be shared, then some pretty strong interventions are needed to avoid the roads being overly congested. So let me get to my five lessons. So what are the 5 lessons that as a project leader of this project that I can share with you? Well, the first is that automated driving is complex and challenging, and maybe people had a bit of high expectations at the start, and even if you see the type of budgets that are being spent in Silicon Valley, but also in Europe, China, and Japan, you would say, oh, this is developing very quickly, and these people are very smart. They can solve lots of problems. Well, it's still very complex and challenging in terms of technology. You either make the road very simple, or you have a very smart car. But still, the number of edge cases that are there are still considerable. So it's still very complex and challenging. We're making steps, but it's much more than a walk ascending the SAE levels. Second lesson is that I think we learned a lot on the common understanding of AV readiness. And you see here a popular table that's being used to express the readiness of countries for automated driving. And there have been several editions of them, but of course we like to show the ones that the Netherlands is high. In terms of policy and regulation, it's technology and innovation. It's about infrastructure and consumer acceptance. And these are important factors that are constituting AV readiness in a safe way. So I think if there's one thing that we've learned in the last couple of years, that yes, there can still be accidents with automated vehicles. We need to be careful in that respect. If they do occur, we need to analyze them carefully, but at the same time, we should not close the door for further development. So we need to keep developing. So we have infra reports that were made, several partners that conducted field studies like Rijkswaterstaat and province of Noord-Holland. And the judgment game was done by Baman with an image-based assessment of road scenes on their suitabilities for AVs, which turned out to be very useful here. A third lesson, and more will be shared also about with Filippo in his presentation. Human factors and supervision are key. So even if a vehicle is highly automated, it could still occur in some cases that a vehicle doesn't know what to do. So you need to be able to signal that, to see what happens there, and to see also how you can intervene and maybe tell the vehicle to behave slightly differently. It's about safety, responsibility, accountability. So who's really in charge and accountable? And also if there is still an interplay between a human factor or a human operator inside or outside the vehicle. So how do they interact? How will they adapt to the situation? Who has which situation awareness? So if the control is shared, then the vehicle and the driver or operator need to share some level of situation awareness. These are really key, and especially when you go to level 3 and level 5, these are very complicated questions. So let me go to level 4, or the lesson 4, sorry. I think a project like STAD, which I experience, is much more than a project itself. So it kind of led to a group of people that I think in hindsight, what we accomplished at the end, the results that we got, if we would have a piece of paper at the start, and we probably would have written something different on it. It's more than a project. It worked together. We developed unexpected results, and also we developed collaboration relationships. So new projects have been emerging from that. Some of them also with a wider scope than just automated driving. So it was also a kind of a learning community that we formed using this project, and I found that very valuable in a project like this. So much more than publishing papers or doing case studies. As a fifth, and I hinted to this already, automated driving is a part of a bigger puzzle. So we won't solve our accessibility and safety issues or urban livability issues just by introducing automated driving. It's clearly part of a bigger puzzle. So there is a claim on space, so and competition for space. So could automated driving lead to a smaller claim on infrastructure and parking? Could it lead to better environmental quality? So what are the impacts on social quality? So will automated driving be for the highly educated, high-income people, or will it be much more accessible in the wider society? Will it improve economic conditions? So will we have shared and electric vehicles? And also, so how will it interact with other modes of transport, which are typically very sustainable, like walking, cycling, and public transport? And what you see here in the graphs is a redesign of the A13 motorways, which can be very, very different if you really take an open mind to redesigning these roads. I'm concluding. In the theory of hype cycles, there is also a path of enlightenment. So automated driving, when it's past it's the peak of the hype, we move to more realistic expectations. So I think the key is to have automated driving in a smart, safe, and sustainable living environment. I think that should be our aim. And the way we do it would be a community of research, application, and learning. As STAD is closing, I can already point you at some other projects that you see. Some of them are NWO funded, Smart Urban Meta Lab, so SUMA Lab, the Urban Mobility Observatory, the Samen project, eHubs, but also at the European level, Shape IT, and electric mobility in Europe. So these are all projects that we are starting work on, and that will also give us a wider perspective on solving accessibility and livability problems in our cities. So thank you for that, and I'll give the floor back now to Wim.
Yeah. Oh. Yeah, thank you very much. Sorry, Bart. Thank you very much for your introduction of your explanation of 5 years' work. It's quite impressive, I must say. I haven't seen any informative question, but I like to ask, like, if they have questions, don't hesitate to type it in the chat. So there's not the opportunity to give you the floor, so you have to do, every question has to come into the chat. Then due to the time, I think I like to move on to the next presentation right away. The next presentation will be given by Filippo Santoni, the CEO. He is assistant professor in ethics and philosophy of the technology at TU Delft and adjunct professor in ethics of transportation at the Politecnico di Milano. He's a rapporteur of the EU Commission Expert Group to advise on ethical issues raised by driverless mobility. He specialized in philosophical and interdisciplinary research on issues of human control and responsibility for emerging technologies. And he's also coordinator, and that's what he's going to tell about, of meaningful human control of automated driving systems. And now I do hope that the presentation can be changed to Filippo. Bart will do that, and then Filippo will take it over.
Yeah, hi, here I am.
Very good. Then I will put my microphone off. Good luck, Filippo.
I just need to move to my own presentation. There we go. Hi, everybody. So I assume you're hearing me. If I don't see any furious message in the chat or any panicking message from the organizers, I'm assuming that everything is going all right from a technical point of view. So yes, so my name is Filippo. Indeed, I work in the section Ethics and Philosophy of Technology of TU Delft. Yes, there is a section Ethics and Philosophy of Technology also in the Technical University Delft, and it's quite a big one. So what we're doing there is indeed analyzing the philosophical, ethical, societal implication of technology. And so today I want to quickly walk you through what we did in the Meaningful Human Control project and to point to some results and impact we've had in the past 3 years. But before then, I just wanted, assuming that it's not the case that everybody in the audience is familiar with ethics of technology or ethics of self-driving cars, I just want to do a very quick presentation of what our take is, what's the background of this project, how did we come to the ideas of this project. So as you know, if you look at the public debate on ethics of self-driving cars, the most common thing you will see is this. So it's this rehearsal of the good old trolley problem that goes back to the 50s that at the time had nothing to do with transportation. So transportation at the time was a metaphor for broader ethical consideration in medical ethics and in other domains. But recently, thanks to the work of Jean-François Bonnefond and others, this trolley problem has gained a new popularity, and you can go to the moralmachine.mit.edu and join the millions of people who have already replied to the survey about how should a self-driving car behave in the possible crash avoidance scenario in which you have to decide who should be sacrificed or rescued in a situation in which there's no way to prevent an accident. Now, in a way, I'm quite grateful to Jean-François and the others who made this thought experiment so popular, because they basically, first of all, they made a great publicity to ethics of technology. Generally speaking, it's the first time in my life in which people have any idea what I'm doing as a philosopher, which is kind of already quite of an achievement when you're out for dinners or for drinks, well, when that was possible with friends. But at a more substantive level, I think the good thing about this approach is that it shows something very important about ethics of technology. It has to do with the time factor. So whenever there is a technological artifact or system out there in the world, the way the system will behave and affect life of people will be determined by choices that have been made long before, during the design stage, the political decision-making about which technology to go. So ethics is something that should be designed into the system if we want it to have an impact and not just being a meaningless discussion. So this is the positive aspect of this approach, or the trolley approach to self-driving cars. Unfortunately, I think there also we thought there were issues with this approach, namely that it's an approach that see ethics as something that comes only in very special circumstances and comes as a dilemmatic scenario. So, technology and engineers know their way, but at some point they will get stuck because there is this really one case they couldn't have predicted. And so here the philosophers or the public should join the conversation. So I don't like that, because I do believe that ethics, as I will try to explain, should be broader than that and should be implemented in the technological process and in the design in a broader sense. And also, I believe that this idea of equating ethics and dilemmas is too narrow. So ethics, thanks God, is not only about dilemmas. Dilemmas are tragic circumstances in which whatever we do wrong, basically. But I think there is a more positive way of looking at ethics, which is trying to guide actions in such a way that you don't end up in these situations where there is no basically way out, so that you prevent getting yourself caught up in these dilemmas in the first place. So this is something I've learned from my colleagues in Delft in the section of philosophy, that, you know, innovation in a sort of a deep sense is precisely trying to prevent dilemmas to occur in the first place, and to create new solutions that allow us to comply with a broader set of values, norms, and interests of stakeholders in society. Another thing we had as a background of this project was some sort of a dissatisfaction with the debates on responsibility for self-driving cars. Again, in the public debate, but also in the academic debate, there had been a great attention for the blame and liability issues. So the question, who's responsible for self-driving cars, was easily turned into the question, who has to pay for an accident, or who is to be blamed for an accident, which of course are very interesting questions. But again, they seem to assume that we don't have any power to guide the process of technological innovation and the behavior of the systems, and the only thing we could do is just to try to fix and compensate or react to mishaps with these technologies. Whereas we thought that, again, important responsibility perspective should be more forward-looking. So how do we have a responsible transition to automation, once in which different actors are aware, able, and motivated to comply and discharge their own obligations, drivers, but also designers, regulators, and so on and so forth. So this was a bit of the background we had in mind when Bart, Marianne, and I started developing the idea of the Meaningful Human Control project. And so basically what we thought, a nice way, this comes from, again, the theory of responsible innovation, where the idea is that we should basically strive for get it all. So we should not start from the idea that we should give up on something. So yes, we do want efficiency, we do want innovation, but no, we don't want to make any compromise with safety or human responsibility. So the idea is it possible? How can we reap all the benefits of higher levels of automation while at the same time keeping a strong control on the technological process and on the technology itself, so as to prevent unwanted outcomes and undesirable social, societal results. And so that's why we put together this nice consortium with Bart van Arem and Marianne Aken-Sicker as senior researchers together with me, and with this nice group of industry and policy partners, and this good grant from the MBO, so the Dutch Research Council. And basically, this was a very interesting experience. It was the first time in my life personally, so I have heard a lot about the necessity of interdisciplinary research at Delft, etc. But this was the first time I was involved in a project which was from the beginning designed to be interdisciplinary. So we came up with this idea of meaningful human control, which I will explain in a moment. And we thought that was a great opportunity to apply this responsible innovation methodology, where you have philosophers trying to come up with a new concept and psychologists testing these concepts in relation to the behavior of people, and engineers, in this case, traffic engineers, trying to model these concepts into the traffic system and see what would be needed in order to really realize this concept in the traffic system. But a bit of background, what is meaningful human control? So the term meaningful human control, as some of you may know, comes from the political debates on military robots, on so-called autonomous weapon systems. So in the past 6, 7, 8 years, there has been a hot debate about how far should we go in the automation of military systems, and what are the risks and benefits, and what would be an ethical and societal acceptable way of introducing AI-based autonomous systems in the military. And so in this campaign and this debate, which was mainly triggered by this campaign to stop killer robots, two main topics emerged as worth being considered with a great attention. One was the risk of, the unpredictability of AI, especially learning AI behaving in unstructured and unpredictable scenarios like present-day warfare is. And on the other hand, the risks of responsibility gaps. The more complex interactive the system becomes, the more difficult it could be for different agents in the network to be held responsible and to feel responsible for the behavior of the system. So in this political debate, there was this agreement that humans, not computers and their algorithms, should remain ultimately responsible for potentially lethal operations. And this was called meaningful human control, as opposed to some form of superficial control where you just push buttons, you are in the loop, but you don't really understand what's going on due to the complexity of the system. Well, we thought that this was a good starting point for a broader project in philosophy of technology and AI, especially because in the literature you would find so many different definitions. Now you cannot read this probably, but it was just to give you the sense of how many different definitions of meaningful human control are there, how many different aspects are highlighted. So at some point we thought with some colleagues in a section philosophy that this was a good opportunity to make a good philosophical exercise and trying to come up with a theory, a framework, an approach to define what does meaningful human control mean, to give some conditions, criteria to assess whether a system, a partially or fully automated system, still is under some meaningful human control. So with a colleague of mine, Jeroen van den Hoven, back in 2018, we published this paper when we proposed two basic conditions for control over technology to be meaningful, which we call tracking and tracing. Basically, tracking has to do with how much the system is able to robustly and seamlessly respond to the relevant goals, reasons, values, norms of the relevant agents in a system. So in the case of self-driving cars, could be the driver, the designer, other road users, etc. How much of this interaction is sufficiently robustly designed into the system in a way that is desirable. And the second condition is the tracing condition, and that's to do with the prevention of responsibility gaps. And the idea is that for a system to remain under meaningful human control, we should design the system in such a way that there always is one human person, at least one, hopefully more, one human person across the design, implementation, development, use chain. And this person should at the same time be aware of the capabilities and limitations of the systems and aware, able, and willing to take responsibility for the outcomes of that. So when we were preparing this project, the application of meaningful human control to self-driving cars, unfortunately, the first fatal accidents with automated vehicles happened. So this picture is kind of fun, but unfortunately, as you perfectly know, there was the first fatal accident involving a vehicle equipped with level 2 autopilot, a Tesla vehicle back in 2016. And then there was another important one in 2018, the Uber accident in Arizona. And so we realized that this was a good test case for our theory of meaningful human control. So we were asking ourselves, were the system tracking the relevant reasons of the relevant agents? Clearly, not sufficiently, right? Nobody wants to crash into a lorry at a crossroad, as it happened with the Tesla 2016. And clearly, there was no good match. There wasn't a good match between the norms and values and goals of different actors in the accident of 2018. And also for responsibility, these two accidents, for instance, were a good example of a situation in which people were starting to point to each other and say, hey, of course, we knew that the company would say, we knew that the technology was not sufficiently good, and that's why we told the driver to remain alert. And in fact, the driver subscribed, undersigned certain terms and conditions. But then the driver or his family could blame the company and say, yeah, maybe there was this contract, but this driver didn't receive sufficient training and was not sufficiently aware of the limitations of the vehicle, and so on and so forth. So what that showed is that even at relatively low levels of automation in terms of the SAE levels, so like level 2, we already have big issues of control and responsibility, and it could be more and more so where we go up in the levels of autonomy. So basically, this is a work that Giulio did together with me on the operationalization of the tracking condition for meaningful human control. So basically, what is the first step we need to take to make sure that the system, whatever level of automation it has, that this system is sufficiently responsive to the relevant intentions, goals of the relevant actors? Well, the first point is that we have a clear map of who these actors are. And whenever we talk about a vehicle, we should not only focus on the right side of the screen, which is, the behavior at the time of action and the interaction with a specific driver or controller, but we go back in time and we broaden the perspective and we design the system to robustly respond and being aligned with the norms, values, intentions, goals of all possible relevant agents who may have a legitimate interest in the behavior of the system, or could be otherwise affected or interacting with the system. But this is more of a cliffhanger, because Giulio is going to present more of the philosophical results of the projects in webinar 3 on 25th of June. And so this was also a way to introduce the other researchers in the project. So Giulio is a postdoc in philosophy. Now, the second obvious challenge for meaningful human control is zooming in on the capacities and skills of the drivers of partially automated vehicles. And this is where the human factor and behavioral science perspective comes in. So Daniel Heiko made some work on this, and this is again just a cliffhanger of one of his papers, where he showed that we should take seriously the idea that there is no direct correlation or inverse correlation between levels of automation and capacities needed. So one may naively think that more automation means less capacities needed from the driver and less responsibility, but it may not be the case. And this work they've done on literature on skills, capacities, and knowledge required from drivers at different levels of automation shows that for sure, at least at level 3, we still have the same number of, or even more, or even a higher number of capacities needed from drivers. And it could be that even at high levels of automation, there still are some important, possibly new capacities and skills needed. But again, I don't want to say too much about this, because Daniel Heiko, our brilliant postdoc in psychology and behavioral psychology, will explain in webinar 5 on September the 10th, so don't miss that one. Now, the third dimension of meaningful human control is the modeling and engineering dimension. And this is one of the many papers that Simeon Calvert has prepared together with other researchers in the project. And this is an attempt at operationalizing the tracing conditions. So this idea that we should be able to measure, to quantify the extent to which there are agents in these complex networks who are able, aware, and motivated to discharge their responsibilities towards the behavior of the system. And so we don't have these responsibility gaps where nobody is really able and or willing and or motivated to take responsibility for the behavior of the system. Not necessarily while the system is on the road, but also the level of design, control, etc. So what Simeon did was trying to create a model to measure the extent to which in a specific automated driving system setting, it is possible to realize the tracing condition, and so avoiding responsibility gaps. Again, even more so here, which is quite far from my expertise, I will just shut up and inviting you to attend webinar 4 on August 27 to listen to our brilliant postdoc in traffic engineering, Wim Korver. Now, before I close this presentation, I also want to share with you something we are quite proud of, which is the impact that this project has. For being a project in ethics and philosophy, with a strong ethics and philosophy component and background, of course, it's also a strong project in behavioral science and traffic engineering, but for being a project with a strong, also with a strong ethical and philosophical component, we've had quite a good impact thanks to the relationship with and the participation of our partners. I will just mention three three sources of societal impact we had. So first, CBR, so the Dutch training and licensing agency, has been a very active partner in this project, and at some point they decided to support the project by funding the creation of this YouTube video on meaningful human control. And why is meaningful human control important? Also from the perspective of new training and licensing policies. So I just invite you to check this 2.5-minute video on YouTube, which shows the interest that CBR in supporting our project and using the meaningful human control idea in their own activities. A second important impact was the following. So 4 years ago, when we were drafting this grant, I got in touch with from the Dutch Ministry of Infrastructure, and they asked me to write this white paper on ethics as self-driving cars. And then I found out via Twitter, these days you find things about yourself via Twitter, and I just found out that at some point it was the most downloaded document from the knowledge agenda of the Rijkswaterstaat. So that was very flattering for myself, but also very rewarding to see that the Dutch audience, or in general, that people are interested in the ethical dimension of the transition to automated driving systems. And from then on, the Dutch ministry, RDB, have been heavily involved in our projects, and we have had the opportunity to have them somehow connecting the ideas of our project to the work of the UNEC work package 1 on global road safety. And so there was a fruitful exchange of information between their work and our work in our project. Finally, this is quite an interesting story too, because I started by mentioning that we wanted to take some distance from the trolley problem and moral machine approach to ethics of self-driving cars, but for some irony of destiny, I ended up sharing this working group at the level of the European Commission with Jean-François Bonnefond, who is actually one of the wizards of the moral machine, and he had been appointed as a chair of this European Commission group on ethics driverless mobility, and I had the opportunity to be a rapporteur of this group. So we are finalizing the report these days as we speak, and so there will be soon a new European Commission report on ethical issues of driverless mobility, which will, in a way, synthesize the moral dilemmas approach and our responsible innovation approach. So you see, there are still people out there criticizing the European Commission, but you see the magic that sometimes they can do in putting together interesting pieces of research. All right, so joking aside, this is what I wanted to share with you. And of course, it's been said that we had to have this meeting online. I hope to be able to have some physical interaction with you in presenting these results, but I hope we will be able to have a discussion anyway online in this way. Thank you very much for your attention.
Yes, Filippo, thank you very much. Interesting to see that there was already impact of your work. So that must be very nice to notice. I will ask Bart then if he could move as a presenter the steering wheel to Jane. And now we have our keynote speaker from the US, Jane Lappin. She is chair of the Transportation Research Board Standing Committee on Vehicle Highway Automation and a founder and organizer of the Automated Vehicles Symposium. Her leadership builds from 3 decades of research, policy and industry experience assessing the impact and implication of road vehicle technologies on traffic behavior and public acceptance.
I'm here and I am helping, yeah.
Okay, I'd like to, I'm almost ready with your introduction. So she's recently retired as Director of Public Policy and Legislative Affairs for the Toyota Research Institute, where she covered global developments related to the safe operations of highly automated vehicles and from the US .FOP Center. Jane, I think now you can put your presentation forward.
Okay, I'm having a little trouble.
You have to push the button on the top.
Stop, confirm. But it isn't selecting my, you see, it's confirming Filippo's.
Oh, see, we had the general preparation that went very smoothly. And
yes.
It
Filippo,
should be the other way around.
Yeah, Filippo, can you turn yours off? Do you think that might matter?
Yes, okay.
You probably need to mark it first before you upload it, Jane.
Well, that's just it. I'm trying to mark it. And the screen tells me that...
And then you have to confirm it at the top of the screen.
I see the confirm, but it isn't marking. It's showing me that Filippo is current.
Yeah. So there's this round thing next to the title. To be
I
flat.
see that now. Thank you. Perfect. Perfect. Thank you. And let's start at the beginning.
There it is, Jane. You can go on.
Perfect. Thank you all. Let me turn on my camera. Well, it's great to be here with you all. I wish we were together, but since I can't be in Delft today, I have with me a Delft egg that I bought when I visited several years ago, and it's sitting next to the computer so that I can feel just a little bit of Delft power and friendliness as I give the talk. The STAD and Meaningful Human Control projects are really significant in their opportunities for informing meaningful public policy. As someone who has bridged between those two worlds for most of my career, it's always stunning to see great work so well targeted and well supported. So today I'm going to take you briefly through my high-level view of the AV world at the intersection of regulators, policymakers, auto manufacturers, tech companies, and road authorities. I want to touch briefly on the specific challenges that each of the key parties are addressing. I'm building to identify a research opportunity that's been unrecognized because we're each focusing primarily on our specific established authorities and more narrowly on the qualifying safety gates that will enable the vehicles to first enter the road. Of course, we want to ensure that the vehicle systems are safe, but once they're on the road, that's where the complexity and my big idea begins. Then, after I take you through that high-level overview, I'm going to share my big idea, ask whether you agree with me, and if you do, what can we do about it? So where are we? On the private sector side, automakers are accustomed to balancing between the twin problem of satisfying the market and satisfying regulators. They're currently bringing forward L2 plus features because these systems fit the existing car market, they're competitive, and they fit the existing models for driver responsibility. The companies are investing in automated vehicles, electric vehicles, and to a much lesser extent, shared mobility. Tech companies are focused on making full-stack, highly automated vehicles. All the billions of dollars that previously flowed into AV startups have slowed. I'm told these investors are now investing in electric vehicle battery chain. This shift in investments has caused some companies to close, while others are looking to sell themselves. So witness Zoox is in negotiations with Amazon. Others, like Aurora, are making productive use of this uncertain time to recruit new engineers and push full steam ahead. Tech companies like Uber are aggressively and publicly addressing AV operational safety because operational safety will have a significant effect on their future business viability. From the public sector, there's a much more complicated sequence of impacts to consider. With thanks to Scott Smith at the Volpe Center, this excellent graphic describes the scale and relationship of cascading impacts that matter to public agencies. Starting at the top with vehicle safety, much of the world's regulatory authorities await the UNECE Working Party 29 to establish regulations governing safe equipment and operations. They're focused on the vehicle and vehicle safety systems. Staying with the vehicle, we have police and first responders, like the man in the previous cartoon, who are working to figure out how they can continue to fulfill their responsibilities without a human driver operating the vehicle. And most of all, really, they want to stay safe themselves in a really dangerous and unpredictable work environment. Moving down the graph, highway officials want to understand how best to plan for a future that includes a mixed and increasingly automated fleet. They want to manage a roadway network that provides a safe and efficient foundation for traffic throughput. City transportation officials are carefully assessing the alternative future scenarios in which AVs can either improve or worsen urban health, mobility, and equity. Long-range planners, moving down to the right, transit operators, and others who are concerned with equitable distribution of AV benefits are looking further down the road to better understand the second and third order effects of an increasingly automated vehicle fleet. So here we have my big idea. At some level of market penetration less than 100%, manually driven vehicles will receive crash protection from level 4 and level 5 automated vehicles, significantly improving public safety for all of the people in all vehicles sharing the road. If highly automated vehicles can't crash, we'll have an opportunity to achieve broad public health benefits through a mechanism known as herd immunity. I invite you to enter into this discussion with me, make it better or disprove it. Perhaps we already have the right data and the right models to identify operating requirements for this crash immunized future. Perhaps all that's needed is a reordering of our approach, a reorganization of existing analyses. If our current models can be applied to qualify AVs as vaccinated public safety agents, what types of policies would we need to achieve broadly safer conditions? I can think of no better audience with whom to have this discussion than with you here in Delft. I'm certain, and particularly based on what's been described today, I'm certain that you have most of this work already done. So from here, I'm going to talk about herd immunity, developing crash disease transmission rates, AVs as vaccinated safety agents. We're going to explore the possible safety outcomes, what proportion of vaccinated AVs we would need to achieve herd immunity, how the vehicles should fit in for an AV to drive safely, and then the question of where to begin. So how does herd immunity work? I think we've all become experts over the past several months. Herd immunity is achieved when a sufficient proportion of people have been vaccinated so that the infection is isolated and cannot be transported from one person to another. Thus, the entire population receives the vaccine's health protection. This schematic shows the shift in disease transmission, comparing an unvaccinated population on the left with a group of highly vaccinated people on the right. Now we see the same chart, but with cars instead of people. We should note that different diseases have different rates of transmission. To estimate the contagious properties of the disease, one must establish whether it's hard to catch, like HIV, where you have to be intimate with another person to catch it, or whether it spreads easily, like measles, where one person can infect 9 out of 10 of the people who surround them. Symptom latency also affects the rate of transmission. Immediate manifestation of these disease symptoms enables quick isolation. Slower rates of symptom development allow the infection to spread further without detection. How would we describe the transmission rate of car crashes? Well, of course, it depends. Vehicle crashes occur most frequently at intersections, on closely packed highways, in wet or slippery weather, at dusk, and at night. Crashing is highly infectious, where the effects of one collision rapidly fans out to affect vehicles surrounding the primary crash. Poor visibility delays driver recognition of the prime crash and increases the probability of follow-on crashes. High speed, crowded highways, and wet weather reduce drivers' ability to avoid the primary crash. How much crash protection can one automated vehicle create for the vehicles that surround it? Consider that highly automated vehicles at level 4 and 5 cannot crash. They can still be hit by another vehicle or a rock, but even where a collision is unavoidable, the AV may be able to mitigate the severity of the impact and thus limit the severity of the impact on the other cars. Further, by detecting an imminent crash in advance of the collision, an AV may be able to maneuver to avoid the crash altogether, saving one or more vehicles from crashing. As an example, one of the Toyota Research Institute's mapping vehicles was hit on a highway in California, and then a third car crashed into the two of them. When the TRI team later simulated the crash and reran it with the vehicle's sensor suite and driving software engaged, the vehicle detected the impending collision, sped up, avoided the primary crash, and resumed safe speed. Gil Pratt described this experience at his talk at CES in 2019. NHTSA, National Highway Traffic Safety Administration here in the US, described the 37 most common US crash scenarios as a basis for prioritizing safety systems. Here again, I'm drawing on the work done by one of my Volpe colleagues, this time the team of Dr. Wasim Najm. But this time, let's examine the different crash outcomes if one of the vehicles is an AV. How would the crash outcome change when we modeled the same pre-crash scenarios with an automated vehicle taking the position of different vehicles within the scenarios? What proportion of vaccinated vehicles do we need to achieve the safety equivalent of herd immunity? The first AVs on the road may disrupt traffic flow because of the differences in their driving behavior compared to human drivers. This initial instability may lead to new crashes. This particular problem is one that the proposed Dutch driving license would address with one of its tests of AV drivability. But the system should be able to quickly learn and integrate into traffic flow with very little observable distinction from human drivers, especially on the more predictable, limited access roadways. We know from modeling traffic calming interventions that we need less than 20% penetration to affect traffic flow. Can we observe positive public safety impacts at lower levels of AV penetration through traffic calming effects? At what level of AV penetration do we begin to see a more broadly distributed safety benefit? And at what level of fleet penetration should AV shift from being go along with the flow drivers to become traffic calming, emissions lowering, throughput enhancing influences of the roadway traffic? I've just skipped a page in my notes. These public health benefits depend upon a safely driven automated vehicle. Safety is partly the result of objective measures like speed, but it's also a function of fitting into the existing driving culture. Consider the famous Pittsburgh left turn or Paris rotaries. This picture is a British rotary above. What position do the authorities take when safe driving isn't the same as legal driving? It's one thing when many different human drivers break traffic laws, each in their own way. What happens when
I think we have a connection issue. Let's see if we can resolve that quickly.
We are experiencing some problems with the connection with Jane, and we're trying to fix that. So I'm sorry, but hopefully she will be back in a few minutes. As you notice, it doesn't work very well at the moment, but maybe you have already some questions for the other presenters, so we can do that in the meantime. So if you have a question for Bart,
Wim?
yes.
Wim? I'm sorry for that.
Okay, I will go out then. Very good. Very nice to have you back.
I'm very glad to be back.
Yeah.
So, but I think I left off on fitting in.
Yes.
Can you hear me? Good.
Yes.
All
yes,
right.
I can hear you. So you can move on. You can start from here.
Excellent. Excellent. So, how should an AV drive safely in mixed traffic? The public health benefits depend on a safely driven automated vehicle. Safety is partly a result of objective measures like speed, but it's also a function of fitting into the existing driving culture. Consider the famous Pittsburgh left turn or Paris rotaries. And this is a picture of a British rotary on the screen. What position do the authorities take when safe driving isn't the same as legal driving? It's one thing when many different human drivers break traffic laws. Each do it in their own way. What happens when a corporate fleet of AVs break laws in their effort to fit safely into the existing flow? What happens when different corporate AV fleets drive differently? Some of us have talked about the need for regional AV driving reference manuals, where scenarios of local driving behaviors can be used to teach the vehicle systems how to adapt and safely fit in. We'll need to address the conflict among legal safe and customary driving behaviors. We know that there's another tipping point when the driving behavior of an entire roadway segment can be shifted to achieve better throughput, improve safety, and lower emissions. We know that we can achieve traffic calming with a fraction of the fleet as AVs if they all observe the same driving behaviors. At what level of fleet penetration should AVs shift from being go-with-the-flow drivers to becoming traffic calming, emissions lowering, and throughput enhancing influencers of roadway safety? So where to begin? If it's plausible that AVs can improve driving safety and provide broad societal benefits, what data do we need to better understand these opportunities? Do our current traffic flow models provide a sound base for estimating automated vehicles as vaccinated safety agents? Can we describe the driving capabilities that are needed for the vehicle system to achieve a vaccinated state? Much of our regulatory concerns, much of our current concerns focus on prevention and protection. What if we turn that around and we focus instead on what we want to achieve, working with the automated vehicle as a public health asset? Thank you for your kind attention today. I really appreciate the opportunity to talk to you. I want special thanks to Stijn de Vrede for his help with the slide template and graphics. And of course, thanks again to Bart for his invitation.
Jane, thank you very much for your presentation. I'm looking at the chat. There was a lot of discussion on all kinds of topics. That was very good to see. I think that can be useful for all presenters to have a look. And I'm looking if there are already specific questions. I saw some discussion on the Rotterdam question, but there were all answers already. Even kijken, here's a question for Filippo. Filippo, maybe you can turn on your microphone and camera. Once we have determined a satisfying ethical framework for the European Union, what leverage would we have to force manufacturers to abide by it, considering international competition? Filippo.
Yeah, so first, just to clarify, the work we have been doing, at least I have been doing at the European Commission, is not going in the direction of creating a framework that should be imposed on actors. It's the opposite. So we are, at least as group involved in ethical issues, we are just trying to identify the ethical issues. And as Jane said, just said in her presentation, it's not the case that every ethical consideration can be translated into a regulation. So ethics, by definition, is something that should be lived by within organizations, etc. So I think the interesting question is how much can and should we regulate through hard legislation? How much should we work to create a culture of responsibility within companies? How much should we work with different kinds of tools? So I think the interesting question is what are the right tools to achieve the right results? And it's not necessarily the case that a common hard regulation is always the case. I do believe that some things do need some hard regulation, but others may be left more to the interactions. Or to other forms of influencing. And the last point is, another recommendation we are giving is, whatever idea we have should be the object of public deliberation. So whatever good idea you may have as regulator, as company, etc., if it is not integrated in a public debate, it will not fly, or will fly and not creating the benefits we wanted to create. So yeah, so it's more complex than that. It's not just about creating a framework and imposing it. Is creating a framework together with some actors and then decide what are the best tools to make it work.
Okay, thank you very much. As a chairman, I would take the opportunity to ask a question to Bart. Bart, the program is called Spatial and Transportation Impacts and Meaningful Human Control. And I saw also a graph of Jane, in which you could see that now spatial impacts are quite complex. And in your the different kind of PhDs topics, or the topic studied, I was now maybe not missing spatial impacts, but it was maybe not the most not the one you spend the most time on. So maybe you can elaborate on that. What do you think? What could be the spatial impacts, or is it even impossible to say something about it?
Thanks, Wim, for this additional speaking time about a subject that I indeed could not devote too much attention on. Yes, so we've worked our way inside out. So I think in terms of the spatial impacts, it's about one topic is about the changes in travel pattern, and that's a spatial pattern. You could also look at the parking space. But for instance, and that happened particularly in a couple of master theses, what if you really are able to redesign your cities in another way? So you get rid of the parking, you have on-demand automated vehicles. We developed some scenarios for that. For instance, in Copenhagen, we developed scenarios for that. In the city of Utrecht, we classified different typical regions of Utrecht and evaluated the attractiveness if you would make that area more green. And we also evaluated how transport flows would be redistributed, what shifts could come from public transport towards public transport or from public transport, and what it would do to the real estate prices. So we used also some land use transport interactions, so Tigris XL for the the ones that are familiar with these types of models in the Netherlands. And one of the students, Martijn Hollestelle, he worked on that, continued work on this topic. I believe Goudappel is also involved in the continuation of that work, and we're also working with TNO on this. Yes, I would have liked to have much more attention to this topic, but we're continuing in that area. For instance, the eHubs project. It's kind of it puts at the center a mobility facility that where you can charge your vehicle, you can get an electric shared bike or a cargo bike or whatever. It's centralized, and by that you free up other space in the city. So we've partly done it as part of the research, particularly also in master projects. I think that was one of the great things of the project, that we were flexible enough with our partners to jump on those opportunities. We have been able to develop some modeling tools for it, but it's certainly an area where there's a lot to explore still.
Okay, thank you. Then there is a question from Bart, by the way, to Jane. Jane, which incentives or nudges could public authorities provide to industry and to users to stimulate herd immunity? Oh, you are. Yeah.
Thanks. And I started to type the answer. You know, the best thing about talking with you at Delft about this is the first step is with you in research to clearly demonstrate what the impact could be and what the preconditions are to achieve that impact. Obviously, the immunized agents, the safety agents, would have different kinds of impacts on different kinds of roadways, you know, different ODDs. But before any of the authorities, before any of the companies can consider what that would mean to them in the future, they have to have it very clearly demonstrated and supported with good data.
Okay, thank you. I think we are already a little bit over time. We were planning to end at 4:30, and it's now 10 minutes before later. So I want to suggest to close this session, but not before I tell you that the next webinar will be held on June the 18th, on the same time, from 3 o'clock till 4:30. And this session will be on the topic on infrastructure. Now, some of the people already were mentioned in the presentation of Bart, but Bahan Madadi, Jeroen van der Gun, and Maaike Snelder will share their work on infrastructure server networks, which networks can facilitate automated driving, and some other topics as well around that area. Now, I think I'd like to thank you all for watching and listening. And what we usually do is digital applause to all the presenters. And hopefully we will see you back on June the 18th. Thank you very much.